moving on, the CMM, or the coordinate measuring machine, is a device that measures the geometry of physical objects by sensing discrete points on the surface of the object with a probe. So that's Wikipedia. We've probably seen a lot of these. The great majority of CMMs rely on the Cartesian coordinate system. This is what you might have learned in algebra, kind of your X, Y, Z planes. That's called the Cartesian coordinate system. So it works like this. Z is in the up and down direction. X is in the left to right, we'll say. Y is front to back. So if you're the operator standing here and the probe of the CMM is moving straight away from you, it's moving in the Y direction. If it's moving right to left, it's in the X. If it's going up and down, it's in the Z direction. So CMMs are available in a lot of different configurations. Here's a popular one, a moving bridge CMM. This is by Hexagon. So you can see the stage. They're usually made out of granite. Now, they could be made out of steel, but a lot of times they're that dark gray granite. You have the part being measured. In this case, it's large. This is a car door. You have this moving bridge. So this bridge, this upside down U right here, it's being driven at the bottom of this foot right here. This is a rail, and there's a motor inside here, and this moves back and forth. This is just rolling, and usually there's a bearing. It's just a rolling bearing. It's not being driven on this side, so one side's driving. So what that does is it moves this probe back and forth along this, and then the head moves over here, so you can get anywhere in that pretty large three-dimensional area. So common, very heavy, require all sorts of specialized installation. A lot of times environmentally controlled rooms and dust-free rooms. They control airflow, velocity, and all this other stuff. Very sophisticated measurement setups going on here. So smaller shop type CMMs. This is called a cantilever CMM by Zeiss. The probe down here, lot smaller stage, much smaller probe. This is probably, I'm trying to think, doesn't look like more than maybe 20 centimeters by 20 centimeters. Perhaps it has shuttles that go back and forth. But anyway, much smaller, and it's cantilevered. In other words, it's leaning out. This is the frame right here, and the whole thing's leaning out. So this is a popular shop floor configuration for a CMM. Other types, obviously very big. This is gantry, so it has the 4 stationary legs, and all the robotics, all the movement happens above ground. These are very large, very sophisticated CMMs. And then a little more shop floor-like, and you can even see, this looks like some sort of machining application. This is a single-arm portable CMM. Sometimes, even though they're portable, a lot of times they get fastened to a bench and they don't move because they're used over and over at the same measurement station. But in this application, if you were some sort of maintenance technician or setup technician, you may actually port it around from one place to another. Faro is the brand. They've been making really cool single-arm CMMs for a long time. So Faro is a popular brand. You'll see them a lot. That's a CMM as well. That's kind of like the low end of CMMs. So CMMs come with different probe types. So touch trigger probes, scanning probes, non-contact probes. So touch probes, they're going to look like scanning probes, and you can't really tell the difference, but in just a photograph like this. But touch probes, touch, they move and touch off on discrete points on the part itself. And there's some sensors inside here that detect force, resistance when it touches a part. So it'll touch and move and move. So they're still made. This is an older style CMM. This is the TP, the touch trigger probe by Renishaw, popular name in probes and styli. So they're still used in a lot, like those single arm Faro CMMs, that would be a touch probe, and you'll see them in older CMMs. A lot of them have been replaced. By the way, that's the stylus. This is a ruby head and stylus. This is that ruby is actually what touches the part. So anyway, here is what we would call a scanning probe. But again, the photograph, it's not this crosshead. That doesn't make any difference. That's just a different configuration of stylus. What's going on in here and with the program is that the probe can scan, it can maintain contact with the part and scan, literally collecting thousands of points on a diameter like this. It really is a better system. It gives you much better, well, it's really more efficient, so CMM programmers can write a program to come in here and just scan this whole inside diameter. If all you have is a touch trigger probe, you have to touch off, touch off, touch off, touch off. The programming's longer, the run time is longer. So anyway, the scanning probe, you get more points, and it's just a more efficient measurement process. So, but Renishaw again makes these probes. So the next type of probe, what we call the non-contact probe, this one by Leica is laser-based. It doesn't actually touch the part, but it gets usually very close to the part and detects the distance between the end of the probe and the part. And in this case, this is a laser, but there's lights, different types of sensors, cameras, vision-based systems that detect and measure, without actually touching the part. So there's a whole wide variety of those as well.